However, right, 6.3 is just using what we learned in 6.1 and 6.2, those identities, the reciprocal identities, and the Pythagorean, our sum, and our double angle identities, and the quotient identity was the other one, to solve or to prove that your left side is equal to your right side. So if I look at my first one here, and make sure I'm recording, okay. Tangent x cos x over cosecant x is equal to 1 minus cos x squared. So if you remember from proving in all of your other math classes that you've done, if you're proving something, you want your left side to equal your right side, so you make that t-chart, and you start doing your proving. So what we want to do when we're looking at this is we want to see what can we manipulate so that we can get that, so that eventually our left side will equal our right side, or our right side will eventually equal our right. So we're going to work with the left side here, because that right side, really, the only thing we could do is one substitution, and that substitution would be 1 minus cos squared x is equal to sine squared x. That doesn't leave me anything more to do. That is kind of as simplified as it gets. So I'm going to work with my left side. So tangent x is the same as sine x over cos x. Can't do anything with cos x, so it's done. Divide that by cosecant x, which is the same as 1 over sine x. Do some simplifying here. My cos x and my cos x will cancel. So what I'm left with on the top is sine x divided by 1 over sine x, or times, sine x. So sine x times sine x is equal to sine squared x. Sine squared x, I know from my Pythagorean identity, is the same as 1 minus cos squared x, which is equal to my right side. So I've proven QED. I can't remember what that means still. Okay, the next one, 1 minus cos 2x divided by sine 2x is equal to tangent x. Well, tangent x on the right side there, I know I could say that that's equal to sine over cosine, but that's about all I can do with it. So that means I'm going to have to do some manipulating on that left side of the equation. Now, same thing as in the last section. That 1, this 1 value here is not a trig identity, so I need to get rid of it. So I have to think, okay, what am I going to do with that cos 2x, that double identity there? Which one am I going to choose of the 3 that I have, double identity for cos, that is going to get rid of that 1? So I know I have, well, cos squared x minus sine squared x isn't going to do anything, so I'm not going to use that one. My other one is 2 cos squared x minus 1, or 1 minus 2 sine squared x. Well, if I put a negative in front of here, because that negative sign here I need to think about, that's going to make this one a plus 1. So I'm going to have 1 plus 1, which is a 2, and I want to get rid of that value. So I know I'm not going to use that one. If I use the second one, negative 1, so negative 1 means I'll have 1 minus 1. I'll get rid of that, and I'll just be left with sine and cos values. So that's the one I'm going to choose to use. I'm going to do this because I don't need as much room on my right side. So this is the same as saying 1 minus 2 sine squared x. Sine 2x is just 2 sine x cos x. So what I have here is 1 minus 1 plus 2 sine squared x. So I've just distributed that negative over 2 sine x cos x. So my 1 minus 1 will cancel. I have 2 sine squared x over 2 sine x cos x. Now I do any reducing that I can. So my 2 and my 2 will cancel. Sine x and one of these will cancel. So what I'm left with is sine x over cos x. And I know that sine x over cos x is just tangent x, which is the same as this side. So my proof is done. Okay, example 3. Excuse me. 1 minus cos x over sine x is equal to sine x over 1 plus cos x. Well, I don't have any double angle identities in there. I don't have any Pythagorean identity. I don't have a reciprocal identity in there. But what I do have, if you look close, is I have conjugates. 1 minus cos x and 1 plus cos x are called conjugates. That means we have the same values, except there's a sign difference between them. Okay? So minus, one is a plus in between. So what you do then is we multiply by the conjugate of, in this case, since this is the denominator, we always want to try to get rid of a denominator. So in order to simplify this so that we can get somewhere in the solving, I'm going to multiply. This side will stay the same for now. 1 minus cos, oops, there's no 2 in there. 1 minus cos x over sine x. So I'm just going to leave my right side for this time. On this side, though, I'm going to use that conjugate to help me. So sine x over 1 plus cos x. I'm going to multiply it by the conjugate. In order to do that, I have to multiply the top and the bottom by the same thing, because in essence, I'm only multiplying by 1. 1 minus cos x, just cos x, simplify just to be 1. So I haven't actually changed anything, but it's going to help me to manipulate this equation. So by doing some expanding here, sine x times 1, so I have sine x. Sine x times negative cos x is negative sine x cos x. On the bottom, do you remember from working with radicals, that was one thing we did, was multiply by conjugates? If I had a radical like this, whoops, just make that a 2, then what I have here is square root 3 times square root 3 is 3, and conjugates basically get rid of your middle term. So this just becomes negative 2 times positive 2, so 3 minus 4. So that's the same thing that happens on the bottom. You're getting, if you're thinking of FOIL, you're getting rid of the O and the I. You're just doing first and last. So I multiply I'm getting rid of my first and first, last and last. I'm only doing my middle, my outside and my inside. Outsides together, insides together, get rid of first and last. So on the bottom there, then I have 1 times 1. Sorry, it's first times first. Oh, goodness sakes. First times first, last times last. So I am just doing the F and the L. So 1 times 1 is 1. Positive cos x times negative cos x is negative cos squared x. So I have sine x minus sine x cos x times 1 minus cos squared x. And I guess I've sort of added an extra step there just for expanding, and I didn't need to. I could have just left this one as sine x times 1 minus cos x. I think if I remember when I did this originally, it was just to show you that if you do have to multiply them out, you have to remember to multiply them to both terms. 1 minus cos squared x, I know from Pythagorean identity, is the same as sine squared x. So sine x times 1 minus cos x. I'm going to do a little bit of reducing here. So my sine x will cancel at one of these. So what I'm left with then is 1 minus cos x over sine x, which was my left side of the equation, so I'm proven. Okay, this last one's a little bit longer. I have 1 over 1 plus sine x is equal to secant x minus sine x secant x all over cos x. So a few more steps to this one. I'm just going to pause for a second. Sorry, I was just going into a little coughing fit there. Okay. So right now there's really not much I can do with this left side of the equation. So I'm just going to leave it as is. And I'm going to see what I can do with my right side of the equation. So secant x minus sine x secant x. Well, I've got a secant and a secant here and here, so I might as well GCF that out. So secant x times, this will be 1 minus sine x all over cos x. Secant x is the same as 1 over cos x. I'm just going to put my divide sign here, this sign here, so that you know it's a divide and not a fraction, all over cos x. So I need to get rid of my numerator. So if I'm dividing by cos of x, that's going to get, that's taking that bar over there and writing it as 1 over cos x times 1 minus sine x divided by cos x. If I rewrite that, that's the same as saying 1 over cos x times 1 minus sine x times 1 over cos x. So if I multiply my tops, and multiply my bottoms, I have 1 minus sine x all over cos squared x. So 1 minus sine x, similar to what I did on the other side, except instead of getting rid of that 1 minus sine x in my, or 1 plus cos x in my denominator like I did there, I'm going to get rid of it in my numerator. So in order to do that, I have to multiply by that conjugate. So my conjugate of 1 minus sine x is 1 plus sine x. And I multiply top and bottom. So what I have then, first times first is 1. Sine x, negative sine x times sine x is negative sine squared x. Oops. And on the bottom, I have cos squared x times 1 plus sine x. 1 minus sine squared x is the same as, using my Pythagorean identity, cos squared x. So I have cos squared x over cos squared x times 1 plus sine x. Cos squared and cos squared will cancel, so I'm left with 1 over 1 plus sine x, which is, whoops, what I had on my left side here. Okay, so sometimes the manipulations that you're going to do aren't going to just jump right out at you. So you're going to have to reduce what you can and then see what you need to get rid of. So multiplying by conjugates is going to be a common thing that you're going to see in a lot of your examples that you'll be working on. Not in a lot, I guess, in some of your examples that you're working on. So if you get to a point where you're stuck, like right here, this one where you're just at this 1 minus sine x, then that's kind of when you can't go any further and you haven't got the left side equaling the right side, then try the conjugate. Okay. Cotangent x minus cosecant x cos is equal to cos of 2x minus cos x over sine squared x plus sine x. Okay, because these ones have some reciprocal functions in there, we want to manipulate both sides of our equation, because in the end, that's what in order to get to where we need. So left side and right side. Cotangent x minus cosecant x. Cotangent x is the opposite of tangent x. Tangent was sine over cosine, so this is going to be cos x over sine x. Cosecant x is the same as 1 minus sine x. So this has a common denominator, so this is the same as cos x over 1 minus sine x. So for right now, I'm going to leave that like that and see if there's something to be done on this side. Okay, so on the top there, I have cos 2x minus cos x. So what I want to do is keep, on the top there, keep all my cos x's. So that's looking at my cos double identity. I don't want to use my 1 minus sine, or 2 sine squared x. I'm going to use the cos one. So I don't want to use anything with the sine, or any of the ones that have the sine, because I want to keep that cos x in there. So I want to keep all of my cos x's on the top. So cos 2x is the same, that double identity is 2 cos squared x minus 1. So that is for this part. And then I still have minus 1. That's divided by sine 2x. We've only got one choice for that expansion. That's just 2 sine x cos x plus sine x. Okay, 2 cos squared x on the top here. This has a power. I'm going from a power of 2 coses to a power of 1 cos to no coses. So I'm going to rewrite that in order. This is the same as saying 2 cos squared x minus cos x minus 1. If I think about that, I'll just rewrite the bottom one. I'm just going to leave this right now as 2 sine x cos x plus sine x. If I think about my denominator, or my numerator here, 2 cos squared x minus cos x minus 1. I'll do the work up here, but you could just do it in your head. This is the same. Oh, hang on. No, I'm okay. By factoring this, this would be the same as saying, doing a decomp. So this would be the same as saying, instead of using cos squared x, I'm going to use a. So this is like 2a squared minus a minus 1. So if I try to solve that one, excuse me, I'm going to have to pause again. Okay. So using my slide and divide to solve for this, and this is kind of a long way around. Once we get to the answer, you might be able just to go straight from 2a squared minus a minus 1 to your answer. So slide and divide, this would be, oops, that color green, a squared minus a minus 2, so I multiplied there. So this is a minus 2 times a minus 1. I'll continue it up here. So then my next step is to divide, so I'm left with a minus 1 times a minus a half, which is the same as a minus 1 times 2a minus 1. Okay? So a minus 1 times 2a minus 1 is the factors for 2a squared times a minus 1. So if I substitute my a's out for my coses, what I have here then is cos x minus 1 times 2 cos x minus 1. So those are that's the factor. Cos x minus 1 times 2 cos x minus 1 is the factors for 2 cos squared x minus cos x minus 1. So now I need to see, what can I do? Well, on my bottom here, I can GCF a sine x out of here. So this is the same as saying sine x times 2 cos x plus 1. Did I switch a sign? I did switch a sign here. There should have been plus 1. There we go. So my 2 cos x plus 1 in the numerator can cancel with the 2x plus 1 in the denominator. That and that will cancel. And I find that I am left with cos x minus 1 over sine x, which is what I have on this side, even though I wrote it wrong. I don't know why it switches for me. Cos x minus 1 over sine x. You're probably wondering way back when why I wrote it like that. Just a mistake. So my left side is equal to my right side, and I'm done. This is why you shouldn't do math when you're sick, I guess. Okay. Next one. Sine 2x minus cos x over 4 sine squared x minus 1 is equal to sine squared x cos x plus cos cubed x over 2 sine x plus 1. Wow, that's a lot of variables and squares and cubes and everything in there. So what we want to do is we want to simplify these. And instead of using sine x and cos x when you're doing the factoring part, substitute in other variables for them so it makes it a little bit easier to do. I'm just going to put a purple line so you can... Okay, so left side, right side. So I'm going to start here on my left side. Sine 2x minus cos x. So sine 2x I know is just my double angle identity of 2 sine x cos x minus cos x. 4 sine squared x minus 1. Well, that is the same as saying 4, if I substitute an a for a sine x, what I have here is 4a squared minus 1. Well, that's just a difference of squares. That's 2a minus 1, 2a plus 1. So I can rewrite my bottom as 2 sine x minus 1 times 2 sine x plus 1. Okay, so now I want to see, can I do any canceling? Well, from my top one here, 2 sine x cos x minus cos x, if I GCF that cos x, I'm left with 2 sine x minus 1. That's convenient because now that gets rid of one of my denominators here. So that means I can cancel 2 sine x minus 1 with the 2 sine x minus 1. What am I left with? Cos x over 2 sine x plus 1. And if I look, I know I'm on the right track here because this is the same as that. So my denominators are the same. So I'm going to jump over to the right side and see what can I do. The sine squared x cos x plus cos cubed x. Well, first thing I'm going to do is I'm working with a cubed. Can I get rid of that? Yes, I can. I can reduce it by GCFing that cos x. That leaves me with sine squared x plus cos squared x all over 2 sine x plus 1. Sine squared x plus cos squared x. That look familiar? Well, it should. That's the Pythagorean theorem. So this is just cos x. Sine squared x plus cos squared x is just 1. So what do I have? Cos x over 2 sine x plus 1. Left side is equal to the right side. All done. So something that looked quite atrocious, actually, to start with, just by doing some simple simplifying, a little bit of factoring, didn't take me very many steps to do. So when you're working on these proofs, keep in mind those identities. There we go. The identities that you've used, the quotient, the sum, the Pythagorean, sum and difference, and your double angle identities to help you with these proofs.